Hello and welcome to a short video regarding programming the PiTrex. The PiTrex is actually a really clever little card, a cartridge actually, which got extended with Raspberry Pi Zero. So here on the top on the GPIO, it gets connected to the card, and then you put it on the right side into the Vectrex. As you see on my machine, there's already one set up and connected. The special thing about that is that it actually combines two machines. So like that, you have a little Linux machine directly on a card connected with your Vectrex. Here in my setup, I have for development a Raspberry Pi 400, so that's included here in the keyboard. I've made the setup, which is described also on my blog article, and with that I can connect from my Raspberry Pi here, which you see on the display, directly over Wi-Fi with the Raspberry Pi on the Vectrex. The smart of that solution is now actually that you have the complete computing power of the Raspberry Pi there, and the Vectrex itself takes ownership about displaying all the vectors, the display of the vectors itself. The advantage of that, of course, is that you have really much more computing power than when you do that directly on the Vectrex itself with a relatively old 8-bit CPU. You have here a full ARM processor, a lot of memory, a lot of horsepower, and like that it's possible to write really games in a different league than it was previously possible to do directly on the Vectrex. How it works that? Actually, a small team of really cool guys have created an API and the card here. And so for a developer as me, it's just kind of easy setup of the toolset. I use C compiler here, normal plain setup like on every other computer as well, and some little make files. I include some basic files from the framework they have created, and with that I'm already able to create little apps or games or whatever. In my case here, I'm working on a chess program because I've tried it initially on the Vectrex itself, but was very limited because of the computing power, and so it was not very fun. The engine I have to use for playing chess on the computer is written in C. It's from another project I have done many years ago and on another platform, and on the Vectrex it never runs really great. So with the PiTrex there's a new opportunity to let the code run on the little machine there on the right, and you see directly then on the display of the Vectrex the output. So I've talked now a lot about that. So in easy words, I create my binary here. So it's really a small one. Actually, I think I have about 5 or 6 C files. Also, I've chosen a little bit of a different approach than the standard examples because I port all my games and stuff I'm doing from other projects. So nothing of that is really written initially for the Vectrex, and so I have also a little middleware is too much. It's a header file more or less which converts from one game engine to the environment of the Vectrex by using the Vectrex interface from the PiTrex project. Actually, it's already done, so the only thing I have to do now is to start the program. And now you see on the display itself here, I get also an output of the chessboard and also of the logic and some debugging feedback. And here on the Vectrex you see directly the result of the chessboard itself. So when I take now the control, first I have to do is start here. You have seen the computer, the Vectrex has directly chosen the first piece. The example here is not really about great chess playing, but showing about how it works. So now I choose, then it goes into syncing mode. You see also here on the display, the chess engine itself runs now on a background thread, and just the refreshing of the display runs on the main thread itself. So you see, most of the time they always take the same stuff. That step he doesn't like so much because it's kind of rookie style, right? So he don't expect that. Needs a little bit longer then to find an appropriate move, but actually, let me do that. You see also the flickering. On that I'm still working because when two threads were running, I have still some synchronization issues here, but it's already much more better than yesterday in the initial prototype. Yeah, that's what I wanted to show. Actually, I can close the program now again, and you see also on the display it stops and it's completely silent now. So no noise, no buzz, nothing in the background. Yeah, that's mainly how it works. I will make another YouTube video then about how you really create the code, what you have to take care of, how it works and so on. So that's a little bit of a different example. This video was mainly about to really show how easy it is to create some code, how to connect, how it looks then, and especially also the progress I made since yesterday with the chess program. So I hope you liked, and give me a thumbs up. See you then, bye bye.